What are rockets hitting in outer space? Or can we even call it outer space? The dome, the glass, are they running into water? Are they running into another gas? A Globe Earther sent me an STS shuttle launch to prove to me that the Earth was in fact a ball. And we're going to examine that just so briefly. But first up, we're going to examine the Go Fast Rocket Team's rocket and see if there's any similarities between that launch and NASA's launch. The Go Fast team first. Okay, so the sound of the engine starts to diminish as if maybe A's run out of fuel or B is being suffocated by something, and so there can be no more combustion. The rocket is spinning really fast still at this point from takeoff. And coming up here, something else happens. And it's right about here, watch. So despite the rocket spinning as fast as it was, something brought this rocket to a complete halt. And now the rocket gets suspended in air and it starts to turn on its side. It's just like floating in something. Now, I don't think this is water because we probably see water on the lens, but I found this very interesting that the rocket just stops, all combustion stops, and now the rocket is on its side and just frozen there in space. Let's compare this to the STS shuttle launch.
Final launch of Endeavour, expanding our knowledge, expanding our lives in space.
Did he say expanding our lives in space or lives? No, probably lives. Let's keep watching. So watch what happens to the second rocket. Pay attention to the flame. We have a nice rocket combustion here, but as everything gets suspended at this point and starts to turn just like the Go Fast rocket started to turn, this flame seems to be pushing against a barrier of some kind or some type of gas as the rocket turns and heads towards Earth, turns its nose towards Earth, and eventually the flame doesn't have any more oxygen and just gets snuffed out. At this point, things get quiet, and all the pieces that NASA set up there start to just slowly rotate as if suspended in a liquid. So everything kind of seems like it's just suspended, bobbing around up there. They're not orbiting Earth because they're not traveling 17,500 miles an hour. They're just kind of stuck up there, spinning around. So let's take a look at this other camera here. Now, the smoke of the rocket most likely would continue in the same direction. It wouldn't orientate with the back of the rocket. But the thrust coming from the combustion of the rocket should follow in line with the rocket, but it's not. It's being pushed by something back towards Earth. It's like there's this resistance to the combustion of this rocket. And one more thing, I probably shouldn't have to mention this, but this is what Globe Earthers think prove curvature of the Earth. Oh wait, that would prove convex Earth. My fault. Never mind. So just like the Go Fast rocket that went up was immediately stopped by something. Something stopped all its momentum, stopped it from spinning, and then it turned on its side and just kind of bobbed in space for a bit, suspended up there. So is this ST shuttle rocket. Everything stops, the combustion stops, something's resisting the combustion, resisting, and just snuffs it out as the rocket is now just suspended in air pointing towards Earth. So what is this? And GLOBEBUSTERS had a show where somebody came on with a German science team who had sent a rocket up. Same thing happened to them. And they claim to have discovered that sitting on top of Earth is a layer of sulfur hexafluoride. Now, sulfur hexafluoride is a gas, and it does not conduct electricity, and it's supposedly sitting on top of our noble gas layer. So let's see what the sulfur hexafluoride looks like. Let's get an idea of what properties we would expect from such a gas. Here we have a tank of sulfur hexafluoride, and somebody has constructed a boat made out of tinfoil. Now, as the boat is placed in the tank, you can see that it actually looks like it's floating on invisible water. Another property of sulfur hexafluoride is that as it gets colder, it starts to crystallize, which could explain these crystal-like formations on the cameras here. Here are the crystals formed on the Go Fast rocket camera as right before it gets suspended. And here NASA's own camera starts to crystallize right when it starts rotating. You can see the little formations, and looks like little ice etchings on the camera actually. And so the guy takes this tinfoil boat, fills it with the sulfur hexafluoride from the tank, and look what happens to the flames of these candles as he pours it over the top. Yep, snuffs the flame out, and this is the exact same thing that we see in rockets. The engines just get cut off, they get suspended temporarily, those ice crystals form, and they fall back down to Earth. Proving once and for all we cannot get in space, and now we have a possible solution or explanation as to what's stopping us. This is Mike. Please like and subscribe.
Remember that when you see a high altitude balloon or that kind of things, the physics itself, if you enter here in OptiWiki, you can find this article that is going to tell you, because the eye of the human eye, is a curved lens. So any curved lens, it's going to result in the image will obviously be circular. So when you looking up in this kind of image, you can clearly see that it's not a curve, downwards. It's just a circle. Of course, the light, it has a lot to do with the imaginary curve, but all the time, the most of the time, when you trying to, the people that, maybe make a pause here and say, no, look at this is a curve, it's a circle. And the physics also telling us.
Sorry, Iru. Bob, yeah. This is what David was deep inside the rabbit hole was saying earlier. He's absolutely correct. The high altitude balloons, when you see them scrolling around with no swing, you'll see it's a flat line all the way around, because the distance really is the same. The only difference is when you enter into the idea of personal observation, when you've made it subjective, and at that point you've got to let go of certain things. But you look at this and it really is completely flat. There's no finding a curve there, because it's not there.
Right.
It's not there.
And we can't see forever, contrary to, popular belief where they say, oh yeah, well, I can see these stars that are thousands of light years away, which that in and of itself is an entirely different argument. Light cannot possibly propagate that far, nor would it. The inverse square law completely annihilates that notion. As well as many other things. I mean, and we've gone into it in detail on several other shows, but yes, there is generally a limit to our eyesight, and so everything that we perceive, if we look around us in a 360-degree circle, is going to be a 360-degree circle. No surprise there, right? But it's amazing how that can be twisted.
Yeah, that's right. This is, for me, I have a video a long time ago where I put in a lot of no balloons, but sounding rockets in perspective, because I have researched a lot for the what is this with the people call the waters above. I have a research on that subject. It's a long subject, but it's very interesting. This super helium or super fluids up there, for me, it's totally clear. But when I make this video clip based on music artists from Argentina, this is like little parts of high altitude rockets, and some ones have a lens corrected, but other ones are just original. And this is our anytime you see this horizon on the top, we are talking about 100 kilometers or 120 kilometers, which is the max you can reach with these sounding rockets, and the horizon are all flat at 120 kilometers up. It's impossible.
Right.
I'm gonna show you, but because the first time of the video clip is just showing that the NASA has a little problem to go up.
Well, it's
So
only impossible in the ball Earth model. Let's make that clear.
Yeah.
Right.
Yeah, exactly. So here is when start the view of okay, I'm gonna leave just to speak on the video, but this is a lot, from Germany, from Switzerland, from Italy. There are a lot of countries trying to reach this maximum altitude, this high altitude, and all the sounding rockets from the 2000 to our days, all is showing the same flat horizon and 100 kilometers, all of.
Yep.
So this is impossible. You need to see some curve in some part of the image, and you didn't see it. So this is with this kind of technology is the most high you can go. If you are talking, pretending that is SpaceX or the rocket that NASA trying to go, out of the planet, there are massive. They are very, very. They have a lot of weight. They can go so up. That is why they curve and go down to the sea or someone else. But they need to make this kind of experiment. They need to build these tiny rockets called sounding rocket that are really, really, light,
Ligero.
exactly, ligero, exactly. So that is the only possible technology to go up at 120. But the problem is when they reach that altitude, what they call microgravity is not microgravity. They are inside in some kind of liquid, but not in form of liquid. They are inside like a heavy, really heavy gas called hexafluoruro. I don't know if you are aware of this, but we are talking about a gas that have 6 times heavier than the air. So you can imagine, you make all these, your aerodynamics, plans to try to break the air, and then in some point you reach a layer which contains a gas 6 times heavier than the air. So how can you going to penetrate that? Right. They call microgravity because they don't show nothing about the microgravity. This is nothing to do with microgravity. You can see even like little sparks of some liquid when they reach down to the earth.
So
this is
I'm a little confused here. So the gas that you're talking about, because Jaren was actually asking about this, the rocket going up, and it appears to like hang in space or whatever, wherever it is. And so you're saying that it's actually going into this gaseous layer And what is that gas called again?
I'm going to show you because it's, an image is better than the words. So
Okay.
especially my words in my English words. So I'm going to try to comment very quickly. Before changing the video, here you can see this is a balloon from the Swiss company, and here you can see clear how the clouds, this evolution of the cloud movement, that is something that never happened in the ISS. When you see that time lapse in the ISS, this never happened, which is something that, it's for me, it's also a ISS killer, if you want to see in that situation. Because when you see something with the ISS, you see, like, I don't know, maybe 6 hours of the time lapse trying to move the robotic arm to catch some something, and you never see this evolution in the clouds, which is, for me, I'm gonna show you what I mean. But when you see this is the original GoPro camera. You can see this time lapse on the ISS, and the cloud, it's static. You should see at least a little of, change in movement clouds, like it's in real life, but you never see. I am, I am a visual effect artist, so I know how this is made, because I have a lot of this kind of. Here I can show you quickly, for example, a model that I made. I working for History Channel a time ago, and I need to. They tell me to recreate the Earth and some satellite, because we have to make an intro to a show called Wonder Moderns. I don't know if you are familiar with that show.
Modern Wonders. Yep.
Yeah, that one. Exactly. So they request, we need to show a satellite out of the world.
That's so funny. So they don't. So even the History Channel doesn't have any stock footage of satellites in space.
No, they don't have. So I am really, when I see all the things that happen on the ISS, I know how they make it, because I make it also. So it's really funny to see that kind of things. So when I'm talking about this layer above, it's a long subject, because the concept, it's like we are the Atlantic, the Atlantida, if you want to think in that way, because we are under some kind of gases, liquid. You can put the name, but this gas is called, let me show you official sites. I have it in Spanish, right? But maybe you can see. It's called SF6.
Oh, hexafluoride. Okay.
Yeah, and this for the official science, they are totally aware the atmosphere is composed with this gas, also with the dioxide. ¿Cómo se dice dióxido de carbono? Carbon dioxide. I don't know if I pronounce it well.
Yeah, carbon dioxide. Yeah.
Yeah.
Yes.
Yeah. So the carbon is 1.4 more heavy than the air, and this gas is 6 times more heavy than the air. So the people in the media, just for fun, they make. Let me show you, because I don't have this this subject ready to go, but I can show you. For example, the media, when get fun with this kind of gases, they show you, and for me it's very interesting what this gas can do. First of all, it's invisible, totally invisible. You doesn't perceive that this box is full of this gas. But when you drop it, some lighter object, they float.
Wow, and this gas is called sulfur hexafluoride.
Yeah, that is the name of this gas. And not just they flow, they act like water. You know, the movement, the turbulence, all that kind of stuff is like water. In fact, you can take and put inside, but you can see how this object sink down.
It's also described, Iru, disculpa, it's also described as having, you'll like this, Bob, excellent electrical insulator. It's part of its qualities is as an excellent electrical insulator. Like, okay, so how is it, if it's so dense, how is it doesn't fall down onto the Earth, given that it's so much denser than the air above which it's situated? Well, it's because I would say, the electromagnetic field of the Earth keeps it apart because it's an insulator.
Yeah, I would tend to agree. I would tend to agree with that.
Yep. Very good.
Yeah. In fact, this gas has the property to, is really heavy. They shoot down all the flames, so that is something that happened to the rockets. Also, it's an electrical isolation, and also is diminish the frequency of the sound. So when you start to, I'm going to show you a few things, but let me just, they drop little bubble, they all leave that floating. I have a video, with very deep analysis of this gas, but I'm going to try to put the parts that I...
Bob, you're going to love this too, because when he shows you the sound properties, I've been doing a lot of research into your video, your balloon footage, and the sound differences when the balloon got higher. You're going to love this. Watch.
Okay.
That's right. And well, here I'm going to put the sound because it's in... No, pardon. It's my voice. But here you can see in the media that they have fun with this. But if you look it's just like a fluid, but it's a gas. All right. Now this gas has a property when the gas get really cold, like 0 Fahrenheit, for example. This gas take a property of crystal. So when you start to to put this all together. Here is the superhelium, properties. When it's cold, they lose all refractive index. So it's totally invisible also. So you can determine if it's something up there or no, because you doesn't have any property of index of refraction. So that is also maybe what we see when we see the light project on the top of the atmosphere. And when you keep going, let me try to... Here you can see there is no index of refraction, for example, which is something really, and then here is a little process trying to... Because this gas has also the color of the ozone layer. When when these kind of gases have a different temperatures, they react some different. It's the same gas, but react different ways, and all that ways that these gases take, this chemical reaction. It's the same reaction that we see when we look up in the sky. For example, the colors, the properties itself. And I'm going to show you a little more advanced. And here is a lot of, kind of videos from DLR, which is a German company. It's a government. Sorry, it's from the government company. It's like NASA, but in Germany.
Right.
And
overpaid liars.
Yeah, yes, that's right. And then also send to the top these sounding rockets, and they found the same thing. They enter in this like microgravity, 6 minutes of microgravity. They cut off the video. But when the stereo see, you can see like maybe the rocket changed some temperature on the air, and because all this happened only when the rockets enter again to the normal, fluid condition of the atmosphere. So it's a little, it's a little strange, because nobody goes top of 120 kilometers, 150 kilometers. No, any ships go, so far, and all the rockets that reach that altitude all have stock on there, and that altitude. And the behavior, in fact, the behavior is like they are on some kind of gas. Yeah.
I was just going to say, I'd like to get me some sulfur hexafluoride. I was just looking into that a little bit. It's pretty interesting stuff, man. It's a hypervalent gas, hypervalent molecules. And so, I mean, I guess that would sort of be like adding a bunch of, like a lot of salt, super salinated water. That's what they put in sensory deprivation chambers, is creates more buoyancy. So do you think that there's, because it makes sense to me that there would be layers of different density gases, even higher density gases at higher levels, if that was conducive for that frequency of the magnetic field at those altitudes, like Antonio mentioned. I definitely agree with that, but I'd really like to get some of that and like fill a car up with it and just have like bubbles floating around in it.
It also makes it has the opposite effect of helium on your voice. So when you inhale it, your voice goes deep.
Yeah. So, I want to show you that. In fact, there is something that I'm trying to forward the video, because I'm trying to to find that part. But also there is something very important for me, because which is on the nature what produce the hexafluoruro of azufre. It's the volcans.
The volcanoes.
The volcanoes, yeah. So that the volcanoes is like, it's which is the nature that has put that barrier on top. Anytime a volcano make eruption, it fill the atmosphere with this kind of gases at, it's uncalculable. You can say how many. So this is, it's part of this kind of the design, intelligent design. In fact, when you see this kind of statistics, the officials say that to 100 kilometers up, the temperatures go down and suddenly go up. But if you never go so up, how do you know?
Yeah.
The problem is that if you continue the line to the point that when the science really can prove this, if you continue this line, it's going to get more cold up there, and if get more cold, it means that this gas is turned into crystals. So that maybe is the reference, in all these religious philosophy that we live in on crystallized dome, on these kind of things.
The firmament.
The firmament, exactly. This gas has the property to transform in crystal if the temperatures go down. All these things that I telling you, I can show you, right? I don't have the material prepared to make the show a little fast, but it's all online. You can research and you're gonna see the same thing that I show you.
Yeah, well, I wouldn't worry too much about that, Eru, because you will be coming back.
Okay, thanks.
You've got tons of great information, and the audience so far is absolutely loving everything that you're presenting. So, absolutely, this is great stuff.
Yeah.
Yeah. So this gas, for the real science, they tell all the equivalent, all the they say, okay, it's up there. It's more heavy than the air, but it's up there because the dioxide of carbon is also more heavy than the air, and it's up there also. So there is this kind of electrical properties that have the firmament, that kind having this kind of gases up there. I also research Eric Dollar things and that kind of thing, and all agree that we live in, in the electrical universe.
Absolutely.